perspectives.
How old are you?
30.
All right, you have 120 years left to live.
Humanity has been chasing the same question for thousands of years. And honestly, it's the question that's been stuck in my head too. Can we live longer and healthier? In the past, the answers to this question were always myths. Immortality elixirs, alchemists, miracle drugs, legends. But today things are different. For the first time, the answers are not coming from mythology, but directly from laboratories, from science itself. Modern medicine no longer sees aging as an inevitable fate. It treats it as a biological process. And it openly says this: it can be significantly slowed down, and in some ways even reversed. This is exactly the point where the focus of medicine begins to change completely. For a long time, what mattered most was how many years we lived, our lifespan. But now, a different concept is being talked about: healthspan. Today, the average human lifespan is around 73 years, but the average healthy lifespan is only about 64 years. That means most of us spend the last 8 to 10 years of our lives dealing with illness, medication, and gradually losing physical and mental function. The goal of longevity medicine is not only to increase average lifespan, but also to close this gap, to achieve healthy aging. The aim is not just to help people live longer, but to remain upright, independent, and mentally strong until the very end. This approach is known as compressing the morbidity gap. Today, scientists have identified 12 fundamental biological processes that drive aging. These are known as the hallmarks of aging. Some of them begin at the most basic cellular level: DNA damage, telomere shortening, epigenetic disruptions, loss of protein balance. Over time, this damage accumulates throughout the body. Mitochondria lose efficiency. Some cells stop dividing but do not die. They remain inside the tissue. These are commonly referred to as zombie cells, and these cells continuously release inflammatory signals into their surroundings. In the final stage, the system itself begins to break down. Stem cells become depleted, the immune system loses balance, and chronic inflammation sets in. Aging is no longer seen as a single cause. It is understood as a chain reaction. Is aging damage or a software error? Here, a very intriguing theory comes into play: David Sinclair's information theory of aging. According to this theory, aging is not merely the accumulation of damage. The real problem is the degradation of epigenetic information that defines a cell's identity. In other words, over time, the cell forgets, what am I and what am I supposed to do? This perspective treats aging not as a hardware issue, but as a software problem. And if software can break, then in theory it can be reloaded or rewritten. The issue of biological age. That's why chronological age alone is no longer considered sufficient. What truly matters is biological age. To measure it, epigenetic clocks are used. By analyzing DNA methylation patterns, the body's true aging state can be calculated. The Horvath clock was the first major breakthrough in this field. Newer systems, such as Dunedin Pace, measure not only how old you are, but how fast you are aging. So two people can be the same age, but one might age 1 biological year per year, while the other ages at a rate of 0.7. Is genetics everything? For a long time, scientists believed that genetics was everything. But today, we know that genetics explains only about 10 to 20% of longevity. The remaining majority depends on lifestyle, environment, nutrition, and behavior. So longevity is not a lottery of luck. It is to a large extent a manageable process. Lifestyle, the strongest influence. Research is very clear on this point. Nutrition, movement, sleep, and social connections directly affect the speed of aging. In places known as the blue zones, such as Okinawa and Sardinia, people live longer and healthier lives. Their common traits are actually very simple: a mostly plant-based diet, continuous but light daily movement, and strong community bonds. When it comes to exercise, the goal is not to exhaust or punish the body. The key is gentle, balanced movement done consistently, without letting the body become inactive. Sleep, on the other hand, is often underestimated today and frequently neglected. Yet it is absolutely critical for DNA repair and immune system function. Modern drugs and interventions. In recent years, some drugs are being discussed not only for treating diseases, but directly for targeting the aging process itself. Rapamycin increases cellular recycling, autophagy. Metformin delays the onset of age-related diseases. GLP-1 drugs rebalance the metabolic system. Senolytics aim to clear so-called zombie cells. These drugs are still in early stages, but the overall picture is becoming clearer. Brain chips. The game is changing. And now we come to the real issue: the mind. Brain-computer interfaces are no longer theoretical. There are real cases where paralyzed individuals can write using only the power of thought. But here, an important question emerges. Is this technology only restoring lost functions, or is it beginning to optimize the mind itself? If memory is enhanced and decision-making is accelerated, if the body stays young while the mind is updated, would a person living 150 years think the same way we do today? Is this a new type of human? When biological longevity merges with technological cognitive support, what exactly emerges? Are we simply creating humans who live longer? Or are we slowly redefining what it means to be human? If the body can largely resist aging, and the mind is supported and enhanced by technology, does the human being remain purely biological? If memory capacity expands, decision-making accelerates, and cognitive limits shift, is this still the same kind of mind we recognize today? Perhaps what emerges is an intermediate form, somewhere between biological human and technological entity. Not fully machine, yet no longer entirely human in the traditional sense. At this point, the discussion moves beyond medicine and engineering. It becomes a philosophical question about the very nature of humanity. Ethical questions. As these technologies develop, a deeper set of questions begins to emerge. Will they truly be available to everyone? Or will extended life and enhanced cognition become privileges reserved for a small, wealthy group? If living longer and healthier becomes technologically possible, does it turn into a basic human right? Or into something that can be bought, sold, and controlled? And perhaps the darkest question of all, when these systems become deeply integrated into the human body and mind, who ultimately decides when a life should end? Nature, medicine, algorithms, or other humans? At that point, the challenge is no longer just scientific. It becomes moral, social, and deeply human. So when we reach the end of this conversation, maybe the real question isn't this: can humans live for 150 years? The real question lies much deeper. Are we, as individuals and as a society, mentally and ethically prepared for such a future? Because it's becoming clear that humanity's future is no longer shaped by time alone. Science, biology, data, and technology are increasingly becoming part of that process. And if these developments force us to make new choices, then perhaps the final question is this: what kind of humans do we want to be? If you enjoyed this video, feel free to like it. And if you want to join this journey of expanding perspective and deeper understanding, you're always welcome to subscribe to the channel. We explore ideas that challenge the way we think, and the journey is better when we take it together.